January 9, question 7. The probability generating function for x could equal -1, therefore there's a term in t for -1 and the coefficient is 1/3. X could equal +2, so there's a term in t squared and the coefficient is 2/3. So that's the answer to part 1. When we get on to part 2, you'll notice that it does say you've got to use the probability generating function. So there are alternative methods which would work, but they wouldn't get you full marks. Thing about gt of t, there's a standard result that this is going to be gx of t to the power of 10, and that in turn is going to be 1/3 t to the -1 plus 2/3 t squared to the power of 10. To find the mean, we would need to differentiate it and sub in 1. So 10 times 1/3 t to the -1 plus 2/3 t squared all to the power of 9. And then using the chain rule, we need to differentiate the bracket, and we get -1/3 t to the -2 and plus 4/3 t. Then we sub in 1, and we get 10 times 1/3 plus 2/3, and the second bracket gives -1/3 plus 4/3. So both brackets reduce to 1, and E of t is equal to 10. And finally, probability that t equals 8. Well, we go back to gt of t, and that, as I say, is 1/3 t to the -1 plus 2/3 t squared all to the power 10. And we've got to think about the expansion of that, and somewhere in that expansion is an expression in t to the 8th. And let us imagine that it actually involves this term to the power of r and this term to the power of 10 minus r. So here we go. 10 choose r times 1/3 t to the -1 to the r and 2/3 t squared to the 10 minus r. And we're basically saying we're comparing powers of t to the -r plus times t to the 20 minus 2r, and that's got to come to be the same as t to the 8th. So next term, t to the 20 minus 3r is t to the 8th, and that means 20 minus 3r is 8 and r is 4. And that means that the relevant coefficient is going to be 10 choose 4 times 1/3 a third to the 4 and 2/3 to the 6th, and that comes to 0.228.